Today we're going to be solving multi-step equations. And so by the end of the lesson, you should be able to say that I can solve multi-step equations. And you'll prove that to me in the quick quiz that you'll take following the video if you don't feel the need to do the post-video questions. And up till now, we've done one-step and two-step equations only. And now on top, I have a few examples of multi-step equations that you're going to see today. But before we begin, there is some essential vocabulary that we need to refresh ourselves on. The first one is like terms. Like terms are terms whose variables and exponents are the same. So an example of two like terms would be 7x squared and 15x squared. Notice that both the variable and exponent are the same. They're both an x squared, hence they're like terms. However, when we talk about combining like terms, what you do here then is if you have like terms already, you simply add the coefficients. And coefficients are the numbers in front of the like term. So if we take this example of our 7x squared and 15x squared, if we were going to add them together, all you do is add these numbers in front. So we would take 7 plus 15, which gives us 22. And you leave the x squared the same. So we notice we don't touch the part that made them the like term. We simply add their coefficients or the numbers in front of the like terms. And this next slide is the 5 steps to solving any equation. And so this is something I would for sure make sure to take notes on, because it's going to come in very helpful in the future. And what you do is when you get to each step, you're going to ask yourself, yes or no? Does it or does it not apply? Sometimes they will, sometimes they won't. If it applies, you then apply the step to your problem. And if it doesn't apply to your problem, you just skip to the next step. So our first step is you do the distributive property. And we'll talk more about the distributive property later when we get to an example using it, but you're going to ask yourself, does my problem require this or no? If it does, you'll apply it. If not, move on. And our second step, once again, yes or no. Our second step is to combine like terms. Once you do that, your goal would be to get the variable on one side of your equation. The fourth step is you would then undo addition or multiplication following that order of operations. And our fifth step would be to undo the multiplication or division. So these 5 steps will help you walk through any type of equation where you need to solve for an unknown. And so it comes in very, very helpful, and it will come in helpful in your future to know these steps. So on the top of all the slides today, you'll notice that I have PEMDAS with our order of operations. And just as a reminder, I have our backwards arrow, letting us know that we would work backwards through the order of operations. And so when we solve for m, if we think back to those steps, do we have distributive property in this first example? No. So go on to step 2. Do we have like terms to combine? And yes, we do. We have a 5m and a 2m. So I'm going to actually combine those first. And I'll be left with 5 equals 7m minus 23. Our third step was to get the variable on one side, which it is. It's all alone right over here. There's no other variables. So then our fourth step is to undo that addition or subtraction. So I have a subtract 23, so let's add 23 to both sides. We're left with 28 equals 7m. And our fifth step is to undo multiplication or division. And all in all, we're left with m equals 4. And so we followed our 5-step solve. and we ended up with our solution. We're going to do the same for our second example. We have to solve for p. We have no distributive property, but we do have like terms. We have an 11, a -8, and -6. What I like to do here is whenever I see a negative or minus sign, I like to think of it as adding a negative number. And then I never forget my negatives when I start combining my like terms. So I would highly suggest that for everyone listening to make them plus and negative when you see a subtraction sign. So I have 11p plus -8p plus -6p. And I actually end up with a -3p, if I did my math right, equals 22. My variable's already alone on one side. I have no addition or multiplication, addition or subtraction to undo. So all my only step is to divide by that -3 to isolate my variable p. And I end up with p equals 22 over -3. Notice how I left my answer. In math, when you're solving equations, it's okay to leave them as improper fractions and to not change them to a decimal. Leave it as a fraction because fractions are better in math. And so just like our last video, now you have some problems to try on your own. So pause the video, go try them, and come back to check your solutions. And so if you give these problems a try, you should end up with, for number 1, y equals 3, number 2, b equals 7, and number 3, p equals -10. If you got stuck on one, go ahead and try it again or come ask me tomorrow in class. Once again, we have more vocabulary words. And so before we can apply the distributive property, we first have to remember what is the distributive property. So the distributive property, when we think about it, you have to look at it in terms of generic. So if we have a number a times b plus c, it also works if this would be b minus c. What it does is you distribute this multiplication of the a times both terms, and then you separate it out. So a times the quantity b plus c, or b minus c, is the same as saying a times b plus a times c. And this plus sign could also be a negative, a minus, and it works both ways. And so that's how the distributive property works, and that's all we need to know for the definition. And so if we think about applying it to our example down here, I'm going to distribute or multiply each term inside my parentheses by that 2, and I'll get 2 times 3 minus 2 times 2x, which will leave me with 6 minus 4x. So I took my item over here, and by using the distributive property and applying it, I end up with 6 minus 4x. And so that is the distributive property. If you forgot, it's a great refresher. And now we're going to have some problems that apply the distributive property. And so when we go back to that 5-step checklist for solving equations, remember how the first one said use the distributive property if you have it. And notice right here, we have the distributive property. So I'm going to distribute my 5 to every term inside, and I'm going to take 5 times 2r to get 10r, minus 5 times 3, or 15, equals 15. And now that I distributed that, I have something that I'm used to seeing once again. And so next we ask ourselves, do we have like terms to combine? No. Get variable on a side by itself, okay? Now undo that addition or subtraction. So let's add 15 to both sides. We're left with 10r equals 30. And finally undo that division. So divide by 10, r equals 3. And so with distributive property, when you see it, I suggest distributing first, and then you can solve like normal, which is really nice because we've already perfected that. And so our next problem is actually one to go ahead and try on your own. 36 equals -8 times the quantity 2x minus 1. Go ahead and give it a try. Come back and check for a solution. For your final answer, you should have got x equals 7 over -4. If you get stuck along the way, go ahead and check out my solution. I skipped a few steps, but see if you can figure it out. Otherwise, come ask me in class like always. And then finally, another type of problem we're going to work with today are fractional problems and combining those like terms. And so there's a few different ways to go about this, but I think the easiest way is you want to get rid of all of the denominators of your fractions. You want to get rid of all the bottoms. And so you need to look at your denominators. And if we look at this first one, we have the numbers 13, 13, and 13. And we have to think, what number do they all multiply into? And well, in this case, it's really easy. It's 13. And so I'm going to multiply everything in here by 13. And in doing so, what I'm doing is that's distributive property. I'm really taking 13 times b over 13 minus 13 times 3b over 13 equals 13 times 8 over 13. And the nice thing about doing this is notice all of my denominators are going to cancel with that 13. And they cancel completely in this case, which is really nice. And so I'm left with simply b minus 3b equals 8. And that's a lot easier to solve than that first problem you were shown. So I'm going to combine my like terms. -2b equals 8. Divide by -2. I get b equals -4 for my final answer. However, if we look at this next example, it's not as easy as this first one. Notice our denominators now are 5, 10, and 5. And so we have to ask ourselves, what's the smallest number that 5 and 10 both multiply into? So it's thinking about going up. So when I look at it, I know 10 times 1 is 10, and 5 times 2 is 10. So that's actually what I'm going to use. I'm going to use the number 10. And in doing so, once again, what you're technically doing is you're taking 10 times n over 5 minus 10 times 3n over 10 equals 10 times 1 over 5. And notice that I'm always using the same number. You can't do something to one item and not do it to the other. You have to keep it consistent. And now when I simplify these fractions, the 10 and 5 don't cancel completely, but the 5 becomes a 1, so my denominator disappeared, and the 10 becomes a 2. And so it's not a huge deal, but don't forget to make that distinction that there might be a number that you're simplifying into. And so I'm actually now left with 2n minus 3n equals 2. By multiplying by that 10, it got me here. Combine my like terms to get -n equals 2. And now I want you to remember that when you see -n, it's really a -1n. There is a placeholder in there. And so we need to divide both sides by that -1 so that we get a positive n equals -2. Because when you solve, a variable always has to be positive. It can never be a negative variable. Here are 2 problems. Try on your own. Give it a try. Come back and check your answers. And notice that when you solve, you should end up with n equals 1 for the first problem and k equals 7 over 25 for the second problem. And I understand that these are complicated. I really do. But it's essential you get them. And so what I suggest is if you're not quite understanding that, make sure you ask tomorrow in class to go over a few more. And I actually am going to have extra work for you guys working on just these types of problems so that we really have a solid understanding on them.